Video series on explaining the bias variance trade-off. And so before I do this, I want to first give credit where credit is due. I learned a lot from both this book, The Intro to Statistical Learning, as well as this particular YouTube video from Ritvik Math. So I would strongly recommend checking out both of those, and I'll post links to both of these resources in the notes of this particular video. But what I wanted to do to kind of offer a different perspective is to show you the bias variance trade-off in code. So what I've got pulled up here is a Jupyter notebook, and we're going to load in a data set and kind of visually see how models can exhibit high bias or high variance. So first things first, in this particular video series, my goal is just to kind of load in the data set and kind of get everything ready. And then in the next few videos, we'll kind of look at bias, and then we'll look at variance in another video. So from this one, we're going to need to pull in pandas. So we'll import pandas as PD, and we'll need NumPy just in case. It's kind of my Swiss Army knife of Python libraries, and I always like to have it handy just in case. We'll also need matplotlib, so we'll import matplotlib.pyplot as PLT. And then finally, we're going to need a few models from scikit-learn. So the model that we're going to use to show high bias is going to be what's called the dummy regressor. And so the dummy regressor, all it does is just predict the mean of your target. We'll see that here in a minute. So from sklearn dummy, we're going to import dummy regressor. And I'm going to tab here to autocomplete. Give it a sec there. So we'll use the dummy regressor as a model to show high bias. We'll use the decision tree to show a model that exhibits high variance. So we'll do the decision tree regressor. And then finally, we'll show you kind of a Goldilocks model, at least for this particular data set, that kind of is the sweet spot between the two. So from sklearn linear model, we'll pull in linear regression. And then finally, last but not least, there's a few other libraries that we're pulling in to kind of show you how you would find bias versus variance in your own data sets. And so one of the most important things you need to do in order to evaluate your model against the bias variance continuum is to train test split. So from sklearn model selection, we'll train test split, and then we'll also look at the cross-val score as well. So there's all the libraries you need. So we'll run that import. And so the data set actually comes from ISLR. So I'm just going to post the URL to this data set. So we're going to set a data frame, and it's going to be equal to PD read CSV. And I'm just going to post the URL here. So statlearning.com/s/advertising.csv. So if you look at this data set, we'll load it in. And so essentially what this is you can think of this as, like, let's say you're a data scientist and you're working for an ad agency, and they're selling widgets, right? So each of these rows represents a market, right? So for example, maybe this first row is New York, the second row is Chicago, and so on and so forth, okay? So for each market, we have a advertising budget that is being allocated across three mediums, right? So your TV budget, your radio budget, and your newspaper. And then the thing that you're trying to predict is how much sales do you make for that particular market, okay? So in regression, these would be our features, TV, radio, newspaper, and sales is our target. It's the thing that we're trying to predict, okay? So one thing I'm gonna do real quick in this particular data set before we kind of get started is drop that unnamed 0. It's just basically an ID column, so we don't need it. So I'll drop columns is unnamed 0. I'll make that permanent, so we'll do in place true. We rerun the cell, and now it's gone. Okay. So first off, I need a list of features. Features is going to be TV, radio, and newspaper. Okay. And so we got that handy just in case, so that we can easily take our data set and just get the features, and it would just give you a data frame of those particular columns. So we have that handy. The second thing I'm going to do is we're going to train our model on the entire data set except for one row. So we're just going to randomly pick a row from this data set, and that's going to be the row that we make our predictions on, okay? So what I'm going to do in order to randomly pull this row is I'm going to call df sample. And I'm just going to sample one row, okay? And so we're going to just pull one row off. Okay, so this will be the row that we use our model to make predictions on. So we're not going to give it to the model for training. We're just going to give it to the model for predicting. Okay, so what we'll do is I'm going to set this, I actually need to set a random state here to get the same random row each time. So I'm going to do a random state, and we'll set it to be, I don't know, 2003. Okay. So this will be our row every single time. So if I run the cell, I get the same row every single time. So we get row 93 in this particular case. So this is going to be my test DF. Okay, so that'll be my test row. The other remaining rows are going to be my training data. So what I need to do is drop this row from the data frame. And then that'll probably be it for this first video, just kind of run it up on a good 5 to 10 minute mark here. And so I want to kind of break these up into smaller chunks to make it manageable. So what we'll do is we'll drop this row from the data frame. So we're going to do df drop, and I want to drop the index. So testdf.index. I want to use that index to drop that row from this data frame. So before I do that real quick, if I get a cell above, we can look and see that we've got 200 rows. So I drop this row from the data frame. So we'll make this permanent. Okay, and then if I do a df shape after that, we're down to 199 rows. So we've successfully dropped that test row from our data set so that the model will never see it. It'll never see it during training, so it's a clean prediction on unseen data, okay? So in the next video, we will start off with a high bias model and kind of show you what that would look like visually speaking. So until then, we'll see you soon.